Two intervals that together equal an octave are called complementary intervals. We can find the complementary interval of any particular interval by simply inverting the interval. Inversion of an interval means moving the lowest pitch of the interval an octave higher so that it becomes the highest pitch, or vice versa, moving the highest pitch of the interval an octave lower so that it becomes the lowest pitch. Let's demonstrate with an example. The inversion of the perfect fifth is the perfect fourth. If we move the lowest note of the perfect fifth an octave higher, it becomes a perfect fourth. The inversion of the perfect fourth is a perfect fifth. If we move the highest note of the perfect fourth an octave lower, it becomes a perfect fifth. These two intervals are complementary intervals because together they equal an octave. The inversion of the major third is the minor sixth, and the inversion of the minor sixth is the major third. These two intervals together equal an octave and are therefore complementary. The inversion of the major sixth is the minor third, and the inversion of the minor third is the major sixth. These two intervals together equal an octave and are therefore complementary. The inversion of the major second is the minor seventh, and the inversion of the minor seventh is the major second. These two intervals together equal an octave and are therefore complementary. The inversion of the major seventh is the minor second, and the inversion of the minor second is the major seventh. These two are also complementary intervals. And finally, the inversion of the augmented fourth is the diminished fifth, and vice versa, and these are also complementary intervals. An easy way to remember which intervals are complementary is with the number 9. If you look back at each of the complementary intervals in this lecture, you will notice that each pair of intervals, when added together, equals the number 9. Here's a chart that lists each interval quality and the corresponding complementary interval. Notice that major intervals become minor intervals when inverted, and minor intervals become major intervals when inverted. Perfect intervals stay perfect, augmented intervals become diminished, and diminished intervals become augmented when inverted.